Good afternoon. Good afternoon, everybody. Good morning for those that are in US, like our keynote. Good night for those that are in Europe. It's a pleasure to present you our keynote, Professor Magy Seif. Thank you very much, Magy, for being our keynote presenter today. It's a pleasure to SBGames to receive you. And before giving the word to Magy, let just me present her shortly her curriculum. Magy is professor in computational media at the University of California, Santa Cruz, where she directs the Game User Interaction and Intelligence Lab. Professor Magy earned her PhD degree from Northwestern University in computer science. Her research focus are basically two goals: developing autonomous tools and techniques for authoring, adapting, and personalizing virtual environments, and developing evidence-based methodologies for measure the effectiveness of game environments through the development of novel in-depth behavior mining and visual analytic tools. Professor Magy worked in collaboration with several game companies during her life, both in serious and entertainment game space. She published the first book on the subject of game analytics, called Game Analytics: Maximizing the Value of Player Data. And she is just launching a new book called on game data science that follows her work on game data science and analytics. It seems that she was just released. Her work is internationally known and cited in several game industry books. Additionally, she has received several awards and recognitions in the game research community. She received 4 Best Paper Awards and 1 honorable mention among the most important conferences. She was named Fellow of the Higher Education Video Game Alliance, and she also serves as Associate Editor of the IEEE Transactional Games and IEEE Transactional Affective Computing and Human-Computer Interaction. So thank you very much, Magy, for accepting our invitation, and we hope all of you have a great time listening to Magy, Professor Magy. Thank you very much.
Thank you. I'm gonna, I think I shared my screen. Okay, I'm gonna just start presentation. Hopefully you're seeing my screen now. I'm going to talk today about user-centric and data-driven approach to game design. And thank you, Esteban, for the great introduction. So you already know a little bit about what the work that I've done in the past, but I'm going to focus particularly on this particular topic. I want to first acknowledge that most of the work that I've done is work that has been going on in my lab. This is my students, my postdoc, software engineer, as well as all the alumni that have been in my lab before and have gone into do wonderful things in other places. I also, most of the work that I'm going to be discussing are funded or have been funded by multiple different institutions, and you can see here some of them are industry, some of them are foundations, and others are could be internal funding and companies as well. So I'm gonna frame it by framing what the open problems that we're trying to look at when we're using user-centric and data-centric approaches to design. If you think about game design in general, and specifically game design for serious games or for serious purposes, you want the design to have engagement, but also retention over time. And retention specifically has been a big issue with not just serious games and games that we maybe develop in the lab, but also games that are developed in companies and apps as well. So if we look at the statistics of how mobile apps have been have kind of audience adherence or retention, you can see that it drops after 7 days and after 30 days. Games specifically average between like 28 to 32% retention, after day 1. After day 7 is about 7% to 11%, and you can see a drop after day 30 to 2 to 6%. Now, this becomes a problem if most of the money is coming from the game and having more users kind of more engaged over time, and also for serious games, because if you are developing a game for education that you want the person to basically go through the game in a semester, a quarter, or a year to kind of gain all of the learning experiences or objectives that you want to get through in the game. After 30 days, 2% is not probably what you want. So retention is a big issue, and we probably want to address that. If we look at how people address it in the HCI world or in games in general, there are multiple different methods that people use, mostly user research methods, to kind of figure out how to tune the design, how to basically develop something that might be better or personalized to specific audiences. And so some of the user research methods that have been used kind of go from qualitative to quantitative and maybe attitudinal to behavioral, where one of the most famous ones in terms of like game analytics is A/B testing. So you can collect a lot of data, mostly behavioral and quantitative, and then you do some studies to figure out how people are interacting with the either the software or the game that you're developing. But you can also do interviews or do surveys. So and these are much more attitudinal side. So this chart is coming from Nielsen and Norman's group, and they basically charted all of the user experience, not just for games, but for HCI in general. The issue with these particular methods is, again, what is engagement and retention, and how do you measure for these in an ecologically valid way? And you can't just bring people to the lab and expect that they're going to engage with an app or a software or a game in the same way that they would do in their own time. And we can't pay people and think that they would be also engaged in the same way either. So you would want to think about how do you do user research when you want to look at engagement, and you can't really give people money for making studies to basically understand how they accept the software. And you also want to test it in an ecologically valid way. So games also have produced their own user research methods, extending what user research methods in HCI or in UX kind of domain. Some of the user research methods have been like playtesting, and they also bring people in the lab to kind of look at usability issues. They mix quantitative and qualitative. This particular screenshot is from a setting that we had at Northeastern, where people are playing, and we were observing how people are playing and then asking them maybe to think aloud or to explain specific things that they are doing as they play. You could also use different sensors to kind of understand the emotional experience as well. Or doing eye tracking to look at where are people looking. Maybe they're missing different things, or they're not navigating the way that you wanted them to navigate. So these methods still face the same problem with engagement and retention and ecological validity that I just mentioned with the other methods as well. So to address that issue of ecological validity, I'm actually going to discuss why is that a bigger problem from an experience I had working with Electronic Arts, specifically on a game developed by BioWare called Dragon Age. Probably a lot of you know Dragon Age. It is not a game that you can just come and sit and play it for 3 hours and it's done. It's a game that you basically play for a long time. Some people even play for a year or two to kind of finish, or some people don't finish at all. What we were looking into is specifically churn, but also we were interested in looking at visual patterns and how that leads to people getting lost in the game and maybe leaving because of that. We used playtesting and we used eye tracking to do that. And what's interesting is that we found a pattern in the data that basically tells us when people are getting lost and probably getting frustrated and leave the game. And then we asked Electronic Arts, or actually BioWare in this case, for the data from people playing at home. And then we compared the two, and we found a lot of this pattern of getting lost behavior that we found in the data from people coming in the lab. The issue was that everybody was exhibiting that behavior, but they were not getting lost in the environment. They were most people would play the game for like 30 minutes, get distracted at home by doing other things, and then they come back maybe a day later, sometimes even 3 months later, and they go around in circles to kind of figure out where they were before. So that kind of like is a reorientation pattern versus a getting lost pattern. And so you could see that it mean different things, and the intent there is very different, but it's the same behavioral markers that we saw in the lab. So that's kind of like why it's important to know, if you want to know the why or the intention behind why people are doing the things that they are doing, it's important to know that in the context of how they're playing. So we also looked at game analytics as a way to engage that kind of question, because with analytics, you could actually log data from people playing anywhere at their own time and pace. And so that brings you a little bit more authenticity in terms of the ecological validity. We went out and did interviews with many different people in the industry, and we put it all together in that book that was published in 2013, discussing how the industry is being basically using game analytics as part of their process. Now we're following it up, as Stephen was talking about, with a new book that is much more like a textbook of the game data science approaches that have been used in games. And the book also has labs with different data, so you can actually try out different things with the data. But going back to game data science or game analytics, what does that mean? It's really just applying data science using game data, where you are collecting, storing, analyzing information, data, making some inferences about this particular data using visualization and machine learning techniques. The types of data that people collect or the industry collects are varied. So some are player action data, so specifically looking at how players are doing different things in the game, and that would get to the design elements that I'm talking about. But there are other uses of game analytics too. You could also collect server data, maybe production, work process, workflow kind of data, or marketing data, user-specific data that is not behavioral. It's much more about the user demographics. So these also, the game analytics in general faces other problems. In order for you to use machine learning techniques, you need to have a lot of data. Most of the time, if you're doing prototyping and you want to tweak the design to the users, you don't have as much data. If you're using a lot of statistical techniques, specifically machine learning techniques, you'll see that you're marginalizing the minorities inside your play, the play data that's coming from specific users. For example, some users may be non-gamers or maybe novice gamers, and so they may not play as much or may not go to specific areas as much, and you wouldn't have that many people, that many data points maybe in your data set, and so you end up marginalizing this because they become outliers. The other issue is that, as I said, sometimes with the story about BioWare, the why or the intent behind why people are doing the certain things that they're doing will vary. And you don't get that from just data. You need to get a little bit more information about why people are doing the certain things they do, which often mean that you want to do some more qualitative research on top of the quantitative research with the game analytics approach. So I'm going to talk a little bit more about our methods, which kind of infuses data with other techniques to kind of get at the question of ecological validity, retention, why users are doing these things that they are doing, but also engages the user early on in the process. So the method that we have derived from working with different industry partners and different partners developing different games basically will target multiple different methods that are engaged in different parts of the production process. So at the concept design level, at the production level, and post-production level. So at the concept design level, as you're still in the concept idea, we mostly use user-centric or motivation models to kind of understand what is the market like and what are the target audience that you want to target, and then how you prepare. If you have specific prototypes or specific ideas, how do you prepare for data collection? What's your KPIs and what's the metrics that you want to define? And that's usually defined at the concept stage. And then at the production, you're doing a lot of testing and user prototypes type of thing, where you're basically doing prototypes and doing some testing with user research methods. We mostly use data-driven experimentation, which I'm going to talk a little bit more about. Because we want to get at the engagement and retention aspect. For usability, we mostly would use play testing or other user research methods that I just talked about from the slides before. At the post-production, now you have the game out there, people are playing, so you can collect a lot of data. So we'll mostly use data-driven experimentation again. We have developed different tools that will allow us to understand a little bit more about the community and engage the community in us interpreting the data. And I'm going to talk a little bit more about that too. So I'm going to talk about the method through different case studies. So the first case study that I'm going to talk about is a game that was developed in 2011. So it's not new. It's called SpaPlay. That game was developed by a company called Ignite Play. The research side that we have done was funded by Ignite Play and Aetna Foundation. And the idea there was that the CEO of the company was interested in developing a game. At the time, Farmville was very popular among the target audience that she wanted to get at. And so she wanted to build something like Farmville. So she built something called SpaPlay, and we helped her build it. And the idea is to combat the issue of obesity, which has been on the rise. And so you want the game to address behavior change to increase healthy eating and exercise. I'm going to show you a video of the game. The voice of the video is actually the CEO of the company.
Hi, my name is Betty, and I've been trying for many years to keep my weight down. And I think I've tried everything. I've tried things like Jenny Craig and Weight Watchers and calorie trackers. But eventually I get bored and I get frustrated, so I just quit. And that's why I'm so excited about SpaPlay, because I love social games, and SpaPlay lets me create my own beautiful health spa resort. But what's even more interesting is that the success of my spa and the rewards that I unlock are dependent on the healthy activities that I do in the real world. So let's take a look. The first thing that I noticed that's really interesting is that the recommended activities, or sparks, are things that I can do in the real world that really fit into my gameplay activity. So why don't you join with me and let's do 5 techniques. 1, 2, 3, 4, 5. Awesome. So right away, I'm getting a reward. I'm getting some positive feedback, and I've gotten a pedometer coupon, which is great because I really wanted to get a pedometer. And it's also cool because this is a reward that reinforces my healthy lifestyle. So let's take a look at the spot. So I'm back, and you can see I've been very, very busy. I've done a lot of healthy activities, and I've unlocked a lot of really cool things. I've unlocked buildings and mini games and contests and all sorts of really fun interactivity. Now, I don't have a lot of time, but let's look at a few of these site features and fun things you can do in the game. So let's start out with the word run game. So I've really had a lot of fun playing the word run game. In this game,
so I'm going to stop it here, but you get the idea. You're basically unlocking different things by doing things in the physical world. For us, we started developing, or we started actually working with the company early on. So we were able to get at the concept design level and use different methods, as I discussed, like motivation methods specifically, to target the user. And so for this particular game, we use self-determination theory as a theory for us to use for design of concepts inside the game to target motivation. And self-determination theory has kind of like 3 different needs or concepts that people basically are motivated by. autonomy, which is basically the sense of control, relatedness, a sense of social connectedness, and competence, which is basically a sense of you feeling competent because you either kind of solved a big puzzle, or you you achieved something big, or you're competing with others, and so you achieved a better ranking, for example. So we took these three different needs or motivations, and we built up gaming strategies and mechanics inside the game that would basically target each one of these. At different stages of the game basically used a very a spiral model for development. So it will develop a prototype, put it out there, see how the users are engaging with it, and then it will add to it as it goes, because everything is online. And so part of these particular game elements have been developed, and the game was out, and then we started to do some more research with it, specifically data-driven research. And so that's the production side, where we use a new method that we developed called data-driven retrospective interviewing. And the idea for this method is to basically take a data-driven approach and combine it with qualitative research. So combine it with interviews particularly, so that we can get at why people are doing the things that they are doing, or the things that are in the data. And so this is kind of like the cycle of how the method works. So we take game data, we process it, abstract it, visualize it, interpret it, and then based on the interpretation of the data, we construct interviews. And then based on the interviews, then we interview people based on these particular interview questions. And then based on that, we start analyzing the data for the interview, and that will allow us to reinterpret the game data, allows us to maybe abstract different things that we haven't thought about, and that kind of cycles through. We collected a lot of different data from the game like that, like all of the time use kind of like activities. So log in, log out, how much time they spent on different things, how much of the objects did they interact with, and the significance of the objects to the game goals, what did they achieve, the XP levels, the quests that they have completed, and so forth. All of the data was timestamped, and so we were able to do some more temporal and sequential analysis. Through this method, we were able to get at usability issues. We also figured out a lot of different aspects in terms of like, how does the game or the application like this adhere to the lifestyle of the people who use it, and how does that kind of influence retention? And also, if we add more personalization, how does that impact retention as well? So I'm going to talk a little bit about results and in the various parts of the production process. So some of this might be early. So early on, we found the game was produced on a website first, and then it was transferred to a mobile. So this particular test that we have done in the beginning was just when the game was on the website. And so people will interact with it, maybe on their off time, and then come back to it later. So one of the things that we found early on when you interpreted the data and visualized it was that we wanted to look at the time they spent on each quest. And so quests are more things like, I'm going to walk to work today, for example, and they accept the quest, walk towards work, then go to work and maybe say, I completed the quest, for example. What we found is that a lot of people, actually not most people, but many people in the population that we looked at actually completed the quest really quickly. Like they accepted, completed within seconds. And so we thought, oh, people are cheating. They're not really doing things in the physical world because there's no, it's an honor system. There is no like specific ways to keep people from cheating. But then when we did interviews with people, we showed them these visualizations. We asked them to annotate the visualizations. We didn't really specifically ask them, why did you do this? And one of the things that came up was that most people not have access to the website for the game, except when they come back from work. So instead of them accepting and then doing work and then coming back and then saying I completed, they basically keep a track of everything that they are doing, and then they go to work, come back, and then they said, okay, I did this, I took the stairs, I did this. So they will basically go to the game and say accept completed, accept completed, based on the things that they have tracked outside of the game. And so that was kind of interesting because we didn't interpret that they would do it that way. And then when the game was out, we started to use the same method but with bigger data and bigger user groups. So we ran many different studies. Some of it was targeted towards like how is the game successful at the behavior change level that we wanted. And so for that, we included 47 participants. We had them play for like 3 months. And over the 3 months, we'll interview them at different points of time. In the beginning, we would get like BMI, demographic info, and we ask them about where they are in terms of behavior change. And that would be our baseline. And then after they play for a little bit, we collect physical tracking information as well as game information. And then we will do interview as well as collect information about their nutrition knowledge, how much do they move in terms of behavior change, and what their BMI, and then we repeat these measures. At the same time, we're getting all of these logs. So during each one of these points where we're collecting that information, we're also doing interviews by visualizing some of the data and asking them to annotate the data to explain what they were trying to do, or any reflection that they want to say about these particular moments of play. We took the interview, and then because we developed the game based on SDT, or self-determination theory, we started to analyze the interview data based on the concepts of self-determination theory, so based on competence, autonomy, and relatedness. And we labeled everything in terms of positive and negative. Did they talk about competence in a negative way or a positive way, for example? We also added integrability to lifestyle because in early and production stage, we found that integrability to lifestyle is becoming a very important variable in terms of retention. And so we also coded the interviews based on that. This is the results that we got at that point in time. And the results show that people who talk positively about autonomy in the game have actually been active more in the game, and they have consistency in terms of their activity. So the mean length between logins is less, and the standard deviation, meaning the variation, is less. The people who talked negatively about relatedness, these are the people who basically said, I want to do this with a friend, I wasn't able to get my friend to do it, that kind of thing. They basically didn't engage as much, and they weren't as consistent. So as you can see already, we know that now retention, and we need to work on the relatedness in the game to increase retention, because we're losing these people basically. Integrability to lifestyle also became an important feature or aspect that we want to design for, because the people who discussed it positively were able to play the game more and be more consistent in their play as well. So this is just a quote from one of the people in the study saying, talking about sparks. So I did them in a way that I could incorporate them into my daily routine better. So I picked the stairs a lot because I live in the 4th floor, and going from the lowest one to the top one is hard. But because there is a spark, I could reward myself for taking the stairs. So in terms of adherence specifically, it varied a lot between different people, but it also varied based on the self-determination theory factors that we were looking for. So this is great because it gives us a why, and it gives us a method for us to basically tune the design. But we also saw for people who are played, there's a positive significant effect on their nutrition knowledge. Their BMI went down, which is good. And the effect size of these are large, which is great. We also did some more statistical analysis to kind of see how consistency of play was a predictor or not, or how it affected BMI and nutrition knowledge. So more people who are consistent playing, the less their BMI is, which is great. Adherence in general was low, and in kind of conclusion of that particular study, and mostly because of the factors that we discussed. But we could resolve them because we know why we need to add more mechanics for relatedness, and that at that time the game didn't have as many. It added so later based on the results of this particular study. And then we also want to address lifestyle issues of people who weren't able to embed the game into their lifestyle. And that means that you want to segment the market and understand the different lifestyles. So you want to do a lot more personalized and adaptive designs. So the method that we use for this particular game or this particular production, we started to apply on many different games. And I'm going to discuss other case studies, including some of these. And the idea there is that when we're starting to develop like data-driven retrospective interviewing techniques or visualization of data, we started to build tools. And that's kind of like the approach that we took is how do we build tools that will enable us to do a better job at the data-driven techniques. So the tools that we used are a lot more on the visualization side. So most people, when we talk about visualization of game data, we talk about like heat maps or things of that nature. We have developed two different tools to allow us a little bit more deeper understanding of what's going on in the game, and also allows us to annotate and qualitatively from researchers' point of view or from even the user's point of view. And we basically, these two visualizations target two different aspects of gameplay. Some games are very spatial and contextual. And so for that, spatial temporal aspects are very important. And some more games, and maybe some games have both, but some more games are more logic-based or puzzle-based. And so the sequence or the logical assembly of how you would problem solve in that particular game and the strategies that you would use would be more important. So their sequence analysis of your actions would be more important. So we developed these two different tools. I'll show what these tools look like. So the first one is the called Strat Mapper, which is basically a spatial temporal one.
Here we are visualizing data from a portion of the match in the game Dota 2. At the center of the application, we have the two-dimensional game map, which can be zoomed and shifted. Below, we have the timeline, which visualizes all of the events in this part of the match. Each event icon corresponds along the y-axis to the event type, along the x-axis to time, and to the color of the event's related unit. Also on the timeline is the brush, which can be used to select a particular time slice. When a selection is made, we see both the color-coded events as well as the units paths through these events update on the map. This brush can be moved programmatically with the playback tools. When an event icon is hovered over, either in the map or in the timeline, we see its details appear in a tooltip. In addition, this icon is highlighted on both the timeline and the map. Units and teams can be selected and deselected here. Event types can be muted in solo here. Notice the update to the map. Lastly, at the top of the timeline are a series of labels. These are used to highlight specific events within the match. When clicked, the brush snaps to that position and the relevant units and event types are selected. In the context menu, the title, author, and description can be seen.
So you could then imagine using this particular visualization to do feature selection. You can also use it to label things like what's a gang, for example, and then use machine learning techniques to kind of take the selected features, the selected portions of different data sets, and then do some more learning to understand what a gang is or what other behavioral or strategic labels that people or the research team has actually annotated on this particular visualization system. So you're using basically this visualization system and researchers qualitative interpretation to do feature selection and abstractions and through annotations. And this can allow for other things that you could do with machine learning techniques later. Glyph, which is the other visualization system, is looking at how people are problem solving in an environment. For Glyph, we started work with Glyph when we started working with a company called Brainquake when they developed a game called Was It Trouble. In this particular game, the game kind of like interface you see here, this is kind of like a difficult level, and we're trying to kind of free the Was It that's inside by moving the cog however many times that the number in that cog says. So if it's 5, then you need to do it clockwise, maybe 2, and that means that it will go 10. So that's the gameplay, and the idea there is that it's the game was developed to help mostly middle schoolers understand algebraic math. Or learn algebraic math. And so we took the game and basically just started to develop a visualization system to allow us to see how people strategize, problem solved, and at different levels in the game. And so the idea there is that we're using like a state map graph where everybody starts in the start state, and then some people may take 2 actions to go to the end, maybe some take longer. And we use this kind of logical abstraction to develop what we call the state graph. But the state graph is basically a representation of how many people went through it. So this could be 100,000 people that went through it, or 5,000 people that went through it. The bigger it is, that means more users went through that particular node. So everybody started at the start state, so this node would be big. But then some people took one route to go to the end, and other people took different routes. And so the arrows that you see there are basically more people going through a particular route, the bigger the arrow is. And so this shows that there is one dominant strategy that most people went through, which is 2 actions to get to the end. But then there are also 3 end states here, which means that people have found different solutions. And that also some people struggled and a little bit going back and forth, for example. So we took that graph and then synchronized with another graph called the sequence graph. So for this particular graph, every strategy, so every going from start to end, is 1 node. And then you have the distance between these nodes is how far or how different the solution is, or the strategy is. And so you can then get clusters. So you can see there are 3 different clusters here, which means that there are 3 different ways of solving this particular level. And even the one that is kind of like the big blob here, there are also subclusters in that, which means that some users have done a very different problem-solving strategy than the others. Using this visualization, it was an interactive visualization, so it allows you to basically pinpoint things and then try to compare different strategies, and then also get a lot more details on exactly the step-by-step that people took. So I'm going to start talking about case studies where we use these visualizations as a way to look at data-driven methods for understanding what the users are doing. One case study is Maze Journey. Maze Journey is a game that was developed by a PhD student in my lab called Shaima Jamali. I'm going to show you the game here. It was funded by NSF, and the game basically is developed to introduce non-programmers to programming using coding techniques that are very similar to Java, but you're doing them inside the game. So in the game, you basically meet different characters. The characters are asking you for help because they're saying that game world is disintegrating because of the code has problems, and so you need to fix the code as you move into from level to level. And you fix the code by getting this interface and then starting to type things to move blocks around. You use many different foundational computer science techniques like for loops or abstraction techniques like object-oriented programming. So using that game, we started to materialize a different way of thinking about methods to understand what people are doing, getting insights of the user. So it became a little bit more complicated. And these methods are not just for Maze Journey. This is for all the games that we have started to look into at the same time. And the idea here is that you have some games that you get data from, and that data gets into a process of abstraction and representation, and you get out of that abstract data model. That abstraction could involve a visualization system like StratMapper, where people are labeling things, or it could just be a data processing kind of technique, a rule-based system type of technique to kind of come up with an abstracted data. And then that abstracted data is what is fed into Glyph that then you show the different problem-solving strategies. And the reason that was important is because if we just take the row-level data and put it into Glyph, you will get an explosion of the different state space because it's just too big. So we needed to abstract it into something that's manageable so that we can see how people are problem-solving and what problems that they are facing. And then we could use that as part of the design. So with Maze Journey in particular, we started with 185 players that played 10 levels, and we got code samples for all the different code that they have completed within the 10 levels. And then we started to look at using Glyph to basically see what people are doing. So most people who were successful had one puzzle and then they corrected it. So this is kind of like a dominant pattern that you see here, where somebody either did something in the game and then went to the end, or they did one particular problem with the puzzle and then went to the end. People who struggled were interesting because they struggled in so many different ways. But there are some patterns that we found when we analyzed the data from Glyph. And these trends are, they didn't solve the error that was a problem in the code. They introduced new errors when they're trying to solve the error that they are doing. They reintroduced old errors that they had in the past, and they made also large changes rather than small changes to the code when they are trying to correct errors. So that's kind of like what we got from that, and what the next step from that, and it's still kind of ongoing project, is that Shaima is now taking all of these results that we got from Glyph to basically feed into an automated system that will produce levels for the players to do to kind of practice issues that they had. So that way we can get them to slowly move on to understand how to correct for errors that they couldn't figure out how to correct in the level because maybe the code that they wanted to write was too big. And so we create the AI system will then create different levels with smaller problems that will tackle the specific issues that they were having. And we're using the same techniques from Glyph to understand what these issues are. We took the similar approach to esports. So you saw the StratMapper, and we had Dota data, for example, and we were able to label different things. So this is a match from Dota, where we basically have two teams in one game and two teams in another game. And we used the sequence graph from Glyph to plot out the different strategies. So you could see in game one right away that the Dire team is very different from the Radiant team. But for game two, the two are almost using similar techniques. So game one was one-sided, where the Dire team basically led early and then continued to win the game, while game two was very balanced. And when we analyzed game one further, we basically used the state graph in Glyph, and we were able to decipher what issues were happening there. So the Dire team was very aggressive. They had more push, more arrows going into the push state than the Radiant team, as you can see in the figure there, and also more gank going to a kill than the Radiant team. With seeing these links, we were able to quickly see what the strategies are, kind of the differences in strategies are that led the Dire team to basically win the game. So I'm gonna go next to what we're working on now. So I talked a lot about the different projects, the esports projects, the Maze Journey projects that was in Trouble and SpaPlay, where we started to develop these different techniques for data-driven design and tuning the design based on data. And so we are basically applying some of that. We have applied it in other projects like VPAL project back in 2013, and we are now applying it on an NSF-funded project called Parallel, where a game that teaches people parallel programming. But we're starting to go further, and I'm going to show you here a talk from Herman, basically, on work that we've done for a Kai paper, and he has done that for his dissertation, where data is now used part of the design and not just as a way to tweak the design or tune the design. So I'm going to have him talk about it.
Is fitness data good enough for motivating people to be active? And how about stories? For centuries, people have been using stories to communicate important values. Hi, my name is Herman Saxono. Today, I'm going to talk about my Kai 2021 paper that shows both data and stories in personal informatics can motivate people and families to be active. But more importantly, both data and stories are powerful, but in different ways. The goal of this work is to reduce obesity, a global epidemic that can lead to diabetes and cardiovascular diseases. Yes, obesity is preventable by having a healthy diet and regular physical activity, but more often than not, obesity is about your socioeconomic status, especially in the US. What that means is if you are poor, then it's more challenging for you to exercise. As a result, it's easier for you to gain weight. Exercising is also a social activity. Decades of research show that it's easier to be active if you have social support. Having family members to motivate you or friends you can exercise with is very, very motivating. So here's the big question. How can we make personal informatics more social in a way that motivates people to engage in healthy behavior? To answer that question, we designed an evaluated story map within the Storywell app. In Story Map, families can do two things. First, they can record their physical activity experiences as stories. This supports self-modeling. And second, they can share their fitness data and stories on a neighborhood map that other families can listen to and get some inspiration. This supports social modeling. This design is guided by social cognitive theory, or SCT, that shows human cognition and behavior are influenced by their social environment. In SCT, our actions are induced by our self-efficacy and outcome expectations, but readily constrained by personal and social environmental impediments that we face. In turn, both self-modeling and social modeling can enhance our self-efficacy and outcome expectations. And in this study, we examine how technology can be designed to facilitate both self-modeling and social modeling. To do that, we conducted an in-depth qualitative evaluation of StoryMap. We recruited 16 families with young children to use StoryMap for 4 weeks. We also prioritized the app for families of low socioeconomic status backgrounds. In total, we got 26 hours of interview data. That's about 672 pages of transcripts, which we analyzed using grounded theory. And this is what we found. It turns out that both data and stories in health technologies are powerful means of health promotion, but they work in their own unique ways. In this video, I will talk more about how social modeling unfolds. If you want to read findings related to self-modeling and model similarities, You can check out our full paper over here. First, seeing other people's data help us to know our adequacy. By seeing how other people similar to you perform, you get a sense of how much is an adequate goal for you. In turn, that enhances your self-efficacy. 2. Stories from other people tell you the steps to achieve the task in being active. That's very motivating because knowing how to do a task enhances your self-efficacy. 3. Stories also communicate positive emotions after exercising. Such stories enhance your outcome expectations. And finally, stories also tell you that your behavior is aligned with your peers' norms. Stories like that validate your action, and you feel confident about your behavior if the outcome expectations are aligned with your peers' norms. To put everything together, this is the conceptual model of technology-supported social modeling. The detail is in our paper.
So as you can see, we're kind of exploring beyond just how to tune the design, but we're also using data as part of the design now. I'm going to also show a video from another project. This is a project about parallel programming. Parallel programming or teaching parallel programming is hard, and students usually struggle a lot. So we developed a game, or the game was developed actually by Drexel University, to look into how do we teach parallel programming in a more playful environment. And so we still found that people still struggle with the game just like they struggle with parallel programming. And so what we were looking into is we did some more studies looking at the data the same way that I discussed earlier using Glyph. But then now we're starting to think about how do we integrate Glyph into the design itself. So that people can learn from other people using the data of other people as well. So this is a sketch. Again, this is still kind of ongoing work. So this is not exactly what it would look like, but this kind of shows you what the idea is that we're starting to look into.
Hi, what you're watching is a modified version of Glyph to accommodate the game Parallel. Parallel is a game where users place semaphores and signals on the boards to make sure the threads do their objectives. Imagine I'm this highlighted player 37023, and we're looking ways to identify me to improve my game. Let me give you an idea on what these colors indicate. A yellow color is basically a dark yellow color means starting the game, while a light red color means that I have a failed test. And the light green color means I've had a successful test. A dark red color means that I failed submission. And a dark green color indicates I've had a successful green submission and I can move on to the next level. As you can see in this particular trace, this player has never had a dark green circle, which indicates that this player has never been able to solve the solution completely and never had a successful submission. Now, as an individual, I'm interested in finding people from my class or my people who participated in my study to understand how to improve my solution. One way which we go about finding solutions, people with similar solution, is using this particular state graph. This indicates each of these blobs on this graph indicate one particular spatial setting. That is, this player has moved from the start to an empty board state and then did some actions of placing and moving semaphores to arrive at a new state, and eventually go on to not solve the solution. At this point, I'm looking at, can I find a player who has reached the similar board state at any point of time while they're playing and actually went on to solve the solution. If I look at a player called 248, I can see that the player has already reached this particular state, but actually went on to solve the solution. Now, what I'm interested is, can I find what this player did to fix my solution? I go to my solution and look at the final state. And I can see this is how I place my semaphores and signals. Now, how do I improve this? How do I actually solve the solution? What did 248 do? Let me go back to his solution. Okay, so even they were wrong at some point of time, and then they actually modified something to actually reach the correct solution. So we want to have a playback feature to have a look at what they actually did. Now, clicking on this particular node will actually give me an indication of what this particular player did to improve the solution. So they started off in a pretty similar state as me, and then they changed their position of semaphores and signals to actually have a successful solution. So this learning is what I take back from watching this player solution, and hopefully I should be able to adjust my semaphores and signals now to actually achieve the correct solution. Thank you.
So, in conclusion, I wanted to just wrap up by saying that we have looked into the use of data and user-centric techniques to kind of and the concept and the production and post-production, and now we're even looking into how do we integrate data into the into the design as well. As a way to kind of encourage or engage people in problem solving, specifically when you are talking about retention and if specifically if users are struggling a lot, how do we nudge them to kind of get to learn how to get to the correct solution by maybe even looking at other people's data or stories to aspire them a little bit more. So again, I wanted to just acknowledge all of the people who have been working on the work that I discussed, and also the funders. And I want to also say that if you are interested in that work or working with us, we have a lot of openings on our master's degrees and the series games, as well as the games and playable media, as well as in the PhD program in computational media at UC Santa Cruz. And I'm going to stop here and ask if there is any questions.
Thank you, Magy, very much for your talk. Very, very inspiring, very interesting. I think it opened a lot of our minds. So we have some questions that people are putting here in the YouTube. If you don't mind, I just want to start a very fast question. Is it Glyph, Magy, ready for use for others? I mean, is it available? We can use it for other purpose, or is it still something closed for your labs or your research?
That's a good question. Most of the time, it takes a long time to abstract the data in a way that is actually intelligible using Glyph. So right now, it's still kind of like a closed within the lab. We can collaborate with others, where we basically work on some kind of agreement where we take their data, we process it, and then we show them visualizations. We kind of may segment the users and do other things and show them that. But I'm also like, I'm starting my own company too to kind of commercialize some of that work. And so hopefully Glyph will be available for people, especially researchers, soon once we make it into a packageable software.
Nice. Let us know when it gets available. So let's run for some questions here. Let me see. Daniel Perazzo, he's asking something more general, I think. He's asking, how does the interaction with the companies and your group start? And do the game companies have specific demands that your group researchers, or does your group come to the company with an idea? So basically, how is your interaction?
Yeah, I mean, I worked on industry collaborations for a long time. It's hard. But mostly it's a relationship that you cannot develop. Trust is an important thing that you want to develop with partners in the industry. One of the lucky things that we've had actually when I was in Vancouver in Canada, we have a lot of funding that goes where the government basically gives half of the funding, and then the industry partner gives half of the funding, and that funds a student and a professor working together with a company. So that was cheap enough for companies to say, okay, let me try different things. So we did something like the BioWare was around that. A lot of the collaborations with EA started like that. And then that started a lot of connections. And I had a lot of different connections too, because I go to GDC a lot and we talk with different people. And so these relationships then started to get us a lot of different contracts to look at different things. Specifically, that they know this is the work that I'm doing, and then they slowly started to integrate data into their process. And so they reached out and they said, okay, we're ready now to kind of explore how we can do this. But with this, because a lot of the research that I'm doing is new and there is no established what is the ROI or return of investment for a company, it's hard to establish that without having case studies showing what the return on investment is. But this is kind of like how it started. And now we have a lot of case studies where we can say that this is what the work that we've done with EA, or this is the work that we've done with Ignite Play. And it was successful in that way.
Nice. Good, thank you. Professor Geber Ramalho is also asking you. He says, congratulations. I've been following your research for a while. Could you talk a little about the risk of data-centric design from an ethical perspective? Just let me put here that Geber gave the first keynote of the conference. He spoke about game data science more. So,
Yeah, I was actually looking at that video.
Oh, okay, nice.
To
Unfortunately, it was in Portuguese, I think, so I don't think, or you, I can't remember if it was in Portuguese or English. Anyway, but he's from the field. All right, thank you.
But yeah, so to answer that question, actually, we did have a paper on FDG just on ethics and data science. In particular, I think if you read the Weapons of Mass Destruction, discussing all of the issues of data science in the society now, you can see what the problems are. And of course, privacy is a big problem. And all of the data that we currently have are not showing any private information. It's all stripped of everything. But still, there are a lot of issues with data ethically, and we're trying to resolve that by making it more open, more transparent. And this is why we started to move towards like open player modeling, like using the data in the design. So now the users know what kind of data that is been collected and how to actually how it's being used and how it's been modeled. They can even edit and correct the model in some cases, and that's one project that we're looking into as well.
Mm-hmm. Yeah. Well, Jeber is just saying he cited one of your papers in the talk, in fact. And actually, after his talk, we got a very nice discussion about this topic. I remember some questions and some discussions about the topic. Very nice.
Yeah, it's an important topic.
Right. Uh-huh. Okay, we have another question from Professor Bruno Feijó. He says, thanks for the inspiring talk, Magy. What do you recommend to consider unintended and negative effects during the early design stages?
Does that mean negative effects because of the use of data or because of...
We have a delay here, Magy, of some seconds.
Okay. So I would assume I would answer that question and then maybe he correct me.
All right. Okay. Yes.
But yeah, so I think this is why we're going for data-driven approaches. So one of the things that happens when you do user studies, if you have user studies with like 10 people, they are only a segment of your market, and they're not a representative sample. 10 is very small. And so it's really hard to drive design results that are actually great because the number of users are small. And so we try to get as many users as we can. And this is why we use data-driven approaches rather than bringing people into the lab and interviewing them. That would be more expensive to do it at scale. And so the approach that we're taking to it is trying to get as many data points from the user segments as much as possible, and we don't really treat outliers as outliers unless we really think that they are outliers. And so we dig a lot more deeper into the data, because an outlier in a sample of like, let's say 200 might be still a segment that you missed in the data collection. And so this is why we dig in deeper into the data rather than just marginalizing things without looking deeper into it. But yeah, I think early in the process, he might still don't have that many people, so he might be doing a lot of decisions. And so I usually in the concept side, it's more of an art than a science. So it's not just data driving all the decisions; it's a designer driving the decisions. So we give the data to the designers. And that's kind of like what the designers take. And then they can just dismiss the data and say, no, I think we're going to go with this. And then we can collect more data and see what happens. And they can not. So it's really the designer driving most of the work in the beginning. And then when you go to post-production, you'll have a lot more data. And so hopefully that will give them a little bit bigger sample set to basically drive design decisions from there.
Thank you, Maggie. Actually, Bruno is saying that this was exactly what he had in mind.
Great.
Great. All right. So there are many congratulations for your work. People that got very happy with your talk. Um, I will end because we are on time. I will end the talk, but I just want to ask you something. When is your new book going to be available, or is it already available?
Yeah, that book should be on Amazon. And the book publisher is also making sure that the digital version is going to be available as soon as possible. The only issue is paper, because with COVID there is just a backlog of paper production. But it should be available very soon, and if it's not already available on Amazon.
Great. Let me go just for the two last comments and questions here. Then we have really to end the talk. Michele Chizuga, she's asking, well, thanks for the talk. Defining time monitoring is a challenge for me. What factors did you consider to define 3 months for continuous telemetry to the study case presented?
Yeah, that's a good point. So that all depends on your KPIs or the measures. Let's say, for example, you have a game that you're developing for learning, and your learning objectives specifically. You know that in a class you would be teaching these over a period of like 7 weeks, for example. Then that's kind of like your time frame. For health behavior change, we know that health behavior change and habit formation take longer than a month. And so we basically estimated 3 months based on the target that we're trying to get at, which is shifting people from being in contemplation or thinking about making a change to actually make a change in their environment or in their physical activity and healthy eating. So that's the idea, is that we're deriving how long does that experiment based on your measures, the goals of the game, or in particular, because the goals will have specific timing aspects.
Thanks. Enio Russo is commenting, thanks, Maggie, for your presentation. He's commenting that posing interesting aspects regarding data-centric and data-driven approach. I think you just proved that we should consider both while designing our solution. And finally, this is real final. Jeber is again asking, are you following the recent developments in the computational creative fields? Lots of interesting protocols are emerging concerning co-creation, artist and machine.
Yeah, that's very true. I think we have about 2 students who are interested in that area and already working in it in my lab.
Okay, so Maggie, let's stop here. Thank you very much for your talk. It was very nice. We are sorry that we didn't manage to bring to Brazil this time. Hopefully, in the next invitation, we can bring you personally to our
Yeah, I
country.
would love to come.
And thank you again in the name of SBGames.
Thank
And
you.
that just me remember everybody that we will have the closing ceremony at 6 today, where we will announce awards and many interesting things. So don't lose. Thank you very much. Bye bye.